Hello all, I am Abhishek Datta and you all are watching my YouTube channel Mathematics Made Easy. Today in this video, we shall be discussing some problems based on improper integrals. In my previous video, I have discussed the types of improper integrals and the procedure of their evaluation. Now in this video, I shall be discussing some problems where I shall apply those procedures to evaluate improper integrals of type 1 as well as of type 2. So let us consider some problems based on improper integrals. So let us first consider a problem given by, say, integral 0 to infinity e to the power minus x dx. Let us consider this improper integral, integral 0 to infinity e to the power minus x dx. So as you can see, this is a type 1 improper integral. Why? Because the range of integration is infinite here. When we call an improper integral of type, when we say that as an improper integral is of type 1, when either the lower limit or the upper limit tends to minus infinity or plus infinity, or both can simultaneously tend to minus infinity or plus infinity. Here we see that the lower limit is finite, but the upper limit tends to plus infinity. So therefore, this is a type 1 improper integral whose range of integration is infinite. And this comes under case 1 as we discussed in my previous video. So to evaluate such an integral, we replace the upper limit by capital X as we discussed in my previous video. So this becomes integral 0 to capital X e to the power minus x dx, and we take limit over this integral as capital X tends to plus infinity. You can watch my previous video about the method of evaluation of such integral. I shall give the link in the description section. Now here this becomes a proper definite integral now, because x is a real number, an arbitrary real number. So we are first taking the range of integration to be 0 to x, and then gradually we shall tend x towards infinity. If this limit exists, then only we say that the improper integral does exist. Now here, as you know, integration of e to the power minus x dx is given by minus e minus x. So here we have limit of x tending to infinity. Here we have e to the power minus x with a minus sign, and this within the limits 0 to capital X, as we normally do in case of a definite integral. So which becomes equal to this minus sign we can take out of the limit, this being a constant, minus 1 we can take out of the limit. So we have minus of limit x tending to infinity, then within bracket we are left out with e to the power minus x. So e to the power minus x means 1 upon ex, 1 upon e to the power x within the limits 0 to capital X. Then we have to substitute the limits here before applying the limit. We have to substitute the upper limit, then the lower limit. So this becomes minus limit x tending to infinity. If I replace small x by capital X, that is the upper limit, so we have 1 upon e to the power capital X minus, if I replace small x by 0, that is the lower limit, there is a rule, first upper limit minus lower limit. So e to the power 0 is 1, so 1 upon 1 gives us 1. So finally we have limit capital X tends to infinite, 1 upon e to the power capital X minus 1. And as x tends to infinite, ex also tends to infinite. So 1 by ex tends to 0. So this portion becomes 0 because 1 upon infinity, this tends to 0. So we have only minus 1 within the bracket with a minus sign outside. So finally the answer becomes plus 1, which is finite. So since we have a finite result, we say this improper integral is convergent and this converges to 1. So this was a type 1 improper integral under case 1. Let us now discuss another problem. Of type 1 improper integral So here in every case the range of integration itself becomes infinite. That is either the lower limit or the upper limit or both tends to infinity. So let us consider the next problem. Integral minus infinity to 0 e to the power 2x dx. So this is also, as we can see, a type 1 improper integral of first kind. The previous one was of, this is the first type 1 improper integral of case 1. This comes under case 1. The previous problem comes under case 2 actually. This comes under case 1, where the lower limit, that is the inferior limit, tends to minus infinity, but the upper limit is finite. In the previous problem, the lower limit was finite, the upper limit tends to plus infinity. So that was type 1 case 2 and this is type 1 case 1. So here, as we have to replace this lower limit by capital X, so we have limit, or first we replace the lower limit by capital X. So this becomes integral capital X to 0 e to the power 2x dx, and we apply limit over this integral as capital X tends to minus infinity. So this becomes, this is equal to limit x tending to minus infinity, integral e to the power 2x is given by e2x upon 2 within the limits capital X to 0. So half we can take out of the limits being a constant. So this is half times limit capital X tends to minus infinity. Here we have e to the power 2x within the limit x to 0. So which is given by half times limit capital X tending to minus infinity. First we replace small x by the upper limit, that is 0. So we have e to the power 0, which is 1, minus we replace small x by capital X, that is the lower limit. So e to the power 2 capital X. And finally, when I apply the limit x tending to minus infinity over e to the power 2x, this becomes e to the power minus infinity because x is tending towards minus infinity. So here we have e to the power minus infinity, which is 0. E to the power minus infinity means 1 upon e to the power infinity, which is also 1 by infinite. So that is equivalent to 0. So this portion becomes 0. So here the answer is 1 and multiplied by half outside. So finally the answer of the limit becomes half. So here also we have a convergent improper integral of type 1. Let us now consider another problem. Of type 2 improper integral. Say we have discussed two problems, both are of type 1. Let us now discuss a problem of type 2 improper integral, that is where the lower limit and the upper limit both are finite, but the function fx will have at least one point of infinite discontinuity within a to b. So let us discuss the improper integral, integral 0 to 1 dx upon x square. So here, as we can see, that this comes under type 2 improper integral. This is our type 2 improper integral because here both the lower limit and the upper limit are finite, but the function, integrand function, that is 1 upon x square, that is the integrand fx, 1 upon x square has the infinite discontinuity at the lower limit itself, that is at x equal to 0. Here the integrand function fx is given by 1 upon x square and fx tends to infinite at x equal to 0. So here the inferior limit itself is the point of infinite discontinuity of fx. So this comes under type 2 improper integral case 1, that is 0 is the tumor point. So on the number line, if this is our range of integration 0 to 1, we have a tumor at the point 0. So we have to cut a certain portion on the right hand side of 0. We cannot cut any portion on the left because the function fx is defined only between 0 and 1. We don't know the nature of fx beyond this. So we have to cut a portion on the right hand side of 0 only because the function is not known on the left hand side. So we cut a portion here and say this length is epsilon. So this point becomes plus epsilon, 0 plus epsilon. So this is plus epsilon. Now we consider the integration from epsilon to 1. So this becomes, if I call this integral I, so I is given by integral epsilon to 1 dx upon x square, and we apply limit over this integral as epsilon tends to 0 plus, because epsilon is this length. So when epsilon tends to 0 plus, that is the length minimizes, this point will gradually tend to 0. So practically we are getting the integration over the entire range. And mind that here we have to write epsilon tends to 0 plus, that is epsilon cannot be negative because it's being a length cannot be negative. So length is always positive. So epsilon has to be close to 0. It must tend to 0 from the right hand side of the number line only. It cannot tend to 0 from the left hand side, because epsilon denotes length here, which cannot be negative. So you must mention epsilon tends to 0 plus in particular. Now here, so the integral is given by limit epsilon tends to 0 plus. Integral 1 upon x square is minus 1 upon x. So minus comes outside. We have 1 upon x within the limit epsilon to 1, because 1 by x square means x to the power minus 2, and by the formula of integration this is x to the power n plus 1 by n plus 1. So x to the power minus 2 plus 1 by minus 2 plus 1, which is x minus 1 by minus 1. So minus 1 comes out and this is 1 by x. And now we apply the upper limit minus the lower limit. So this is equal to minus limit of epsilon tends to 0 plus. First we replace x by 1, so we have 1 here, then minus we replace x by epsilon, so 1 minus 1 by epsilon. Now you see, finally when we replace epsilon by 0, so this portion tends to plus infinity, because 1 upon 0 tends to, this is 0 plus, so this portion tends to plus infinity. So basically we are having 1 minus infinity here. So which is minus infinity? 1 minus infinity is minus infinity with a minus sign outside, so practically it becomes plus infinity. So this whole thing tends to plus infinity. So we say this improper integral is divergent, because this practically tends to plus infinity. So this was a type 2, an example of a type 2 improper integral. And this comes under case 1 of type 2 improper integral, that is where the inferior limit itself is the only point of infinite discontinuity of fx. Let us now consider another example of type 2 improper integral. Let us consider this case, integral 0 to 2 dx upon 1 minus x whole square. So as you can see, this is also a type 2 improper integral, because both the lower and upper limits are finite, and here the integrand fx, which is given by 1 upon 1 minus x whole square. So this becomes infinite at x equal to 1. So x equal to 1 is the only point of infinite discontinuity of fx, which is an interior point of the range of integration 0 to 2. So here we have infinite discontinuity at an interior point of the domain of integration. So this comes under case 3 of type 2 improper integral. So here, if this is our number line, the integration is taken from 0 to 2, and here exactly at the middle point 1 we have the tumor, that is, this is the tumor point or the point of infinite discontinuity. So here what we have to do, we have to cut a portion on either side of 1, because the function is defined on either side of 1. So you have to cut a portion on either side of 1, but we can cut portions of different lengths. In one side, say a length of epsilon 1, the other side we cut a portion, a length epsilon 2. Normally we have to consider different lengths on either sides. So here we have a point 1 minus epsilon 1, and here we have a point 1 plus epsilon 2. So this is the portion 1 minus epsilon 1 to 1 plus epsilon 2, which is being cut out from the interval 0 to 2 to remove this tumor 1. So therefore this integral I, if I call this integral I, so we now consider I in the range 0 to 1 minus epsilon 1 dx upon 1 minus x whole square, and we apply limit upon this when epsilon 1 tends to 0 plus, and plus the second integral, that is 1 plus epsilon 2 to 2 dx upon 1 minus x whole square, and we apply limit over this when epsilon 2 tends to 0 plus. Now, if both the two limits exist, then we shall say that this improper integral exists. Now, to evaluate this thing, you can substitute 1 minus x as t. So, dx becomes minus dt. So, this is to evaluate this integral, if we put t equal to 1 minus x. So, we have dt which is minus dx, or dx becomes minus dt. So, the integral becomes dx is minus dt upon t square. Now, integral dt by t square is minus 1 by t with a minus sign outside. So, practically this becomes plus 1 by t, and again if we replace t by 1 minus x, this becomes 1 upon 1 minus x. So, I am directly writing the answer here, that is integral dx by 1 minus x whole square is 1 by 1 minus, because it is a very elementary integration. I think you all must be accustomed with all these type of integrations, a very simple substitution type. So, I am directly writing the answer here because of shortage of space. So, this is 1 upon 1 minus x in both the cases. So, this becomes equal to limit epsilon 1 tends to 0 plus, this is 1 upon 1 minus x within the limit 0 to 1 minus epsilon 1, and also here we have plus limit epsilon 2 tends to 0 plus, again we have 1 by 1 minus x within the limits 1 plus epsilon 2 to 2. Now, we have to replace x by the upper limit minus the lower limit. So, this becomes equal to limit epsilon 1 tending to 0 plus, if we replace x by 1 minus epsilon 1. So, we have 1 by epsilon 1 here, and again if we replace x by 0, so we have minus 1, then plus limit epsilon 2 tending to 0 plus, replace x by 2 here. So, we have minus 1, 1 by 1 minus 2 minus 1, minus replace x by the lower limit, that is 1 plus epsilon 2. So, this is 1 upon minus epsilon 2. So, basically here we have minus epsilon 2. So, this minus minus makes this plus. Now, if I replace epsilon 1 by 0 and also epsilon 2 by 0, both these two portions becomes infinite. 1 upon 0 plus, here also 1 upon 0 plus, both these two portions becomes infinite. So, hence both the limit does not exist. If at least one of them does not exist, we say this improper integral does not exist. So, therefore, finally we shall say that this improper integral does not exist because both the limits tends to infinity. Here this one tends to minus infinity, because as epsilon tends to 0 plus, this thing is infinity, minus 1, sorry, this tends to plus infinity, and here also this tends to plus infinity, minus 1 plus infinity, and here we have infinity minus 1, same thing, minus 1 plus infinity here, here also minus 1 plus infinity. So, both tends to infinity. So, hence finally this improper integral is divergent, they does not exist. Now, if it so happen that in case 3, type 2 improper integral case 3, that is while we have a point of infinite discontinuity as an interior point of the domain of integration, if I choose equal portions, if I cut equal portions on either side of the point of discontinuity, that is from the tumor point, if you cut equal portions on the either side, sometimes it may happen that though individually the limits does not exist, if you take epsilon 1 and epsilon 2 to be equal, then they may exist. In this case, if I take epsilon 1 and epsilon 2 to be equal, then also they doesn't exist. But just for sake of example, I am saying if we have such a case, say here we have 1 by epsilon minus 1 limit epsilon 1 tending to 0 plus, and then we have limit epsilon 2 tending to 0 plus, say 3 minus 1 upon epsilon 2, say we have such a result. So, here you see, here also both the limit does not exist, because as epsilon 1 tends to 0 plus, epsilon 2 tends to 0 plus, both of these limits tends to infinity. So, the improper integral does not exist. But if you consider epsilon 1 equal to epsilon 2, that is if I cut equal length on either side of 1, then if I replace epsilon 1 equal to epsilon 2 by epsilon, that is epsilon 1 equal to epsilon 2 equal to epsilon say, then these two terms 1 upon epsilon 1 and minus 1 upon epsilon 2, they cancel each other, because if I take epsilon 1 and epsilon 2 to be equal, this also becomes plus 1 by epsilon and this becomes minus 1 by epsilon. So actually if I take, so here the limit becomes limit epsilon tends to 0, 1 by epsilon minus 1, plus again limit epsilon tends to 0, because they are same now, epsilon tends to 0, 3 minus 1 by epsilon. So we can merge the two limits, that is limit epsilon, here we cannot merge them because this limit is over epsilon 1, this limit is over epsilon 2, but when they are equal, both the limits are on epsilon, we can merge these two functions, this plus this, we can take limit epsilon tends to 0 over this plus this, that is the property of limit. Then you see plus 1 by epsilon and minus 1 by epsilon, they get cancelled. Plus 1 by epsilon and minus 1 by epsilon get cancelled. Then the answer becomes 3 minus 1, which is 2, which is finite. So then this improper integral exists. This improper integral do exist. So that value is then referred to be the Cauchy principal value of the improper integral. But in reality, we shall say the improper integral is divergent, but its Cauchy principal value is said to be 2. So Cauchy principal value, we shall say that the improper integral exists in Cauchy principal sense, in Cauchy principal value sense, but not in real sense. That is, in general, we are not permitted to take epsilon 1 and epsilon 2 to be equal. But if it so happen that taking epsilon 1 and epsilon 2 to be equal, we are getting a finite result because these two terms cancel each other, then that finite result is said to be the Cauchy principal value of this improper integral, though the improper integral will be still divergent in real sense, but we shall say that the improper integral converges in Cauchy sense, and that value is known as the Cauchy principal value. But in this particular problem, here in our particular problem, this improper integral does not exist in real sense, neither in Cauchy principal value sense, because here if you take epsilon 1 and epsilon 2 to be equal, then also these terms does not cancel, because here this was the actual step forward. This is the actual problem. So here if I take epsilon 1 equal to epsilon 2 to be epsilon, we have 1 by epsilon and also 1 by epsilon. So they don't cancel each other. So here still they becomes, the improper integral becomes divergent. So this improper integral is divergent in real sense and also in Cauchy principal value sense. But there are improper integrals which may not exist in real sense, but they may have a Cauchy principal value. So this was the example of a type 2 improper integral under case 3. So in this video we have discussed some problems on improper integrals of type 1 as well as of type 2. In my next video I shall be discussing some more problems on improper integral, and also we shall be discussing two particular type of improper integral known as beta function and gamma function. They are very important types of improper integrals. Beta function and gamma function, they have their huge application in the field of dynamics and also in various other researches of mathematics. So we shall be discussing those concepts, beta function and gamma function, and also some more illustrations upon type 1 and type 2 improper integral in my upcoming videos. I hope this video is helpful to you. If you have any query, you can ask me in the comment section. I will try to answer them. Please like this video. It will help my channel to grow. Also subscribe to my channel, and I wish you all the best and Happy New Year to all of you. Today is 27th of December 2017. So I wish you an advanced Happy New Year and also a Merry Christmas. Thank you all for watching.